Yes, sir, you are audible.
Yeah. Okay. So although this is a tutorial class, so due to first tutorial class, I will convert it into the lecture. Okay. So this class will also be considered as a lecture.
Recording in progress.
From the next class onwards, next tutorial class, you will have separate tutorial class where we will discuss numerical problems based on the questions given in the tutorial. Okay. So I will share first tutorial by the end of this week, and we will discuss the tutorial problems in the next week. Okay. Okay. So I will share the contents, and then in the morning class we have discussed about the basic fundamentals of parameters that are used in electrical and electronics engineering, that is charge, current, voltage, power, and what is the passive convention in this in power. Okay, we have seen that what is the significance of positive power and negative power. Similarly, we have also seen that what is the significance of positive current and negative current. Okay. So now we will start our basic topic, that is starting with the network, difference between circuit and network. Then we will see the types of elements. Okay. And after that, we will also see about the circuit solving techniques. So I will also share this content to you, where all definitions, all basic definitions are given. Okay. These are very basic fundamentals for every students, whether it is from any branch. So it is very basic fundamental that is taught in the first year, and that you should remember throughout your 4 year. Okay. So if there is question related to this fundamental in your interview, then you can be able to answer. Okay. So in the morning class, we have seen that means I told you about the network and circuit. Okay. So you can see here the network is in the context of electrical and electronics engineering is a collection of interconnected components such as resistors, inductors, semiconductor devices, transformers, sources. Okay. Means it is an interconnection of passive elements and active devices, some active devices. And the network analysis is the process of finding the voltages across and current through all network components. Okay. So in other words, the combination of various electric elements such as inductor, resistor, inductor, capacitor, voltage sources, current sources, connected in any manner whatsoever, is called an electrical network. Okay. So first we can classify the elements in two parts, passive elements and active elements. We all know that resistor, inductor, capacitor are passive elements. So what are the active elements? And why they are called as a passive elements? Resistor, inductor and capacitor, why they are called as a passive elements? Okay, so they are called as a passive elements because they don't have its own energy. Okay, while whereas the active elements has its own energy like sources. If you talk about the current and voltage, they have its own energy and they can be able to drive a circuit or network. Okay, so that's why they are called as active elements. So what are the example of active elements? Example of active element will be sources, different types of sources. Okay, and devices also. Later on, you will see why the devices means transistor. Suppose transistor is there. So why transistor is an active element? Why not passive element? So transistor is an active element because it has some energy, and if we uh, introduce in a circuit, so based on the introduction of the transistor in a circuit, our device will activate. Okay, so the direct and indirect example of active element is transistor also. Okay, so the difference between circuit and network is the second part, where we have seen that a circuit is a combination of elements like resistor, inductor, capacitor along with sources, but it must be a closed one. Okay, so there must be a closed path. There must be a closed path between in means among the circuit element and sources. Okay, so circuit must have a closed path, whereas network may or may not have closed path. Means they the current flowing through the components may or may not be there in the network, because network doesn't have closed path. It may or may not have closed path. Okay, so closed path is not mandatory for network, whereas it is mandatory for circuit. Okay, so the circuit current must pass through all the elements. In the circuit, current must pass through all the elements, but in the network, current must not pass through all elements. Okay, so this is the very basic fundamental difference between circuit and network. Means in broader sense, we can say that network is a circuit. Network is a type of circuit, whereas all circuit cannot be considered as a network. Okay, there are other networks also, means linear and non-linear network or circuits. So network can also be further categorized in various parts. So linear network are those network which have linear components, which have linear component present in that network. Okay, like linear components are resistor, inductor, capacitor. They are called as a linear network, linear elements. So the network which has linear components or linear elements, these are called as a linear networks. And the relation between voltage and current must be linear. It means there must be means V by I, that is the ratio of voltage and current must be constant. Okay, whereas nonlinear circuit means the circuit which has some nonlinear elements. So nonlinear elements, the best example of nonlinear element is diode. You can see that a PN junction diode is considered as a nonlinear element, Why it is called as a nonlinear element? Can anyone tell why PN junction diode is called as a nonlinear element?
Because IV graph is not straight line and not passing through origin.
Yes. So in diode, we can see that in VI graph, there is not linear relationship between voltage and current. Means there is no straight line in this VI graph, and the current exponentially increases after a certain point. So that's why this diode, PN junction diode, is called as a nonlinear element. Okay. So when in any circuit, when there is a diode, existence of diode is there, so this network or circuit is called as a nonlinear circuit or nonlinear network. Okay. Active and passive elements. So I have already told you the difference between active and passive elements, and it is the one of the basic categorization of elements. Okay. Active elements, passive elements. Example of passive elements are RLC, resistor, inductor, capacitor. And why they are called as a passive elements? Because they don't have its own energy. Okay. Whereas active elements are the elements which have some energy in it, and they can be able to drive the circuit. Okay. Or they can be able to supply energy to the other component. So that element is called as an active element. Okay. So the example of active element we can see, we have already discussed that all the sources, whether they are voltage or current sources, they are considered as active elements. And also transistor is an example of active element. Okay, so these things you should remember. Next is unilateral and bilateral elements.
Excuse me, sir.
Yeah.
Sir, is resistor an active element?
Register, no, register is an passive element. Register is a passive element.
Okay, sir.
Okay, because register has no any energy in it. Okay. So next categorization is unilateral and bilateral elements. So unilateral means the current flow is unidirectional. Okay, if the current flow is unidirectional in particular element, that element is called a unidirectional element or unilateral element. Whereas bilateral element means the current flow can be possible in both directions. Okay. And if we consider in both directions, so the property of element will not change. So those elements are called as a bilateral elements. So the conduction of current in one direction is termed as a unilateral. For example, you can see diode transistor. Diode transistor conducts. When they conduct, then only the current will flow. Okay. Like when we consider the example of diode. So in diode, you know that the two terminals are anode and cathode. So if there is a positive, means P and N. So if there is a P type is provided positive supply, N type is provided negative, then only diode will conduct. Okay. So when the diode will be in forward bias, then only it will conduct, it will be able to conduct. So that's why in this forward bias only diode will conduct, and current flow can only be possible in forward bias. In reverse bias, ideally, there is no current flowing through the diode. So that's why it is considered as a unilateral element, or you can also call it as a unidirectional. So current flow is unidirectional. So the example of bilateral elements, you can consider the passive.
Excuse me, sir. Hello.
Yeah.
Then what about a Gino diode?
Zener
do
diode
conduct,
Zener diode is also considered as a unidirectional. Okay, it is also a unilateral element.
but it do conduct electricity current in reverse bias.
Reverse bias, yes. So it is conducting in only one direction, right?
Yes.
It is not conducting in forward bias.
Mm-hmm.
It is conducting in reverse bias only.
Okay. Thanks.
So all semiconductor devices are unilateral, but diac is a bilateral element. Okay, the diac is a power semiconductor device, so it is only a bilateral element, and all semiconductor devices means all transistor, all diodes, they are unilateral elements. Okay. All linear elements are bilateral, but reverse is not true. Okay, all linear elements means
Whose graph is whose VI graph is straight line.
yes. So in VI graph, we can see the relationship between voltage and current must be linear. Okay. So the graph between voltage and current will be a straight line. And so all linear elements are bilateral. So linear elements means all passive elements, resistor, inductor, capacitor, all are bilateral elements, but the reverse is not true. Okay. Next, we will discuss about passive elements and the relationship VI voltage and current relationship. Okay. So in resistor, you know that this is a symbol of resistor where the current flowing is I. So voltage across resistor will be V. So voltage across resistor is multiplication of resistance multiplied by current, or in other words, we can write IT is equal to VT upon R. Okay. So there is a linear relationship between voltage and current, or you can see here the resistor is a static element. Okay, it means it doesn't depend on time. Okay. And also it doesn't store any energy. So that's why it is also called as an energy dissipating element. It can only dissipate energy, it cannot store energy. Okay. Whereas capacitor and inductor, they will store energy in the form of magnetic field or electric field. Okay. So the next is capacitance, where you can see the symbol of capacitor is there, current flowing through the capacitor I, and voltage across capacitor is V. So the relationship between voltage across capacitor and current is related by the charge through the capacitor. So QT is equal to CVT, Q is equal to CV, you know that. So the current, we know that IT is equal to dQ upon dt. So if we differentiate this CVT, we can write C dV by dt. So I is equal to C dV by dt. Or in other word, we can write dV by dt is equal to 1 upon C IT. And by integrating both sides, dV by dt, integration dV by dt is equal to Vt minus Vt naught. Vt naught is the initial value, initial stored voltage across capacitor. So we can write 1 upon C integration T naught to T, I tau d tau. So it means Vt can be written as Vt naught plus 1 upon C integration I tau d tau, where Vt naught is the initial stored voltage in the capacitor. So you have to remember, and I think you have already studied in your 11th, 12th the relationship between voltage and current in inductor and capacitor. Okay, so inductor is a dynamic element where dynamic means the voltage across capacitor will change with time, and it stores energy. It stores energy in the form of electric field. Okay, and also capacitor opposes the change in voltage across it. Okay, so that you should remember. Similarly, for inductor, we can see that if the current through inductor is I, voltage across inductor is V. So the relationship is Vt is equal to L di by dt, means voltage across inductor is equal to L di by dt, means rate of change of current. It will depend on rate of change of current. So di upon dt is equal to 1 upon L Vt, and for the current through inductor, the expression of current through inductor we can denote here. It is equal to I naught plus 1 upon L integration T naught to T V tau d tau, where IT naught is the initial stored current through inductor. Okay, it is also a dynamic element. It is also considered as a dynamic element because here voltage across inductor or current through inductor depends on that. It will change through time, and also it stores energy just like a capacitor. So the stored energy will be in the form of magnetic field, and it opposes a change in current. So means it opposes the sudden change in current through inductor. Okay, so sudden change of current through inductor will not be there. Similarly, sudden voltage change will not be there in capacitor. So that basic things you have to remember. Next is electrical sources. About electrical sources, so there are various types of electrical sources. Firstly, they can be categorized as independent and dependent sources. So independent and dependent sources are further categorized in voltage and current sources. So what are independent sources? Independent means the value of voltage or current will not depend on any other parameter. Means that value will be fixed throughout the time. Okay, it will not change and it will not depend on any other parameters. So these sources are called as independent sources. So current sources and voltage sources both are independent sources. Some dependent sources are there. So in dependent sources, the sources depends on other circuit parameters. Means suppose if there is a circuit and in particular branch current, if the source is depending, that is considered as a dependent source. Okay, so it may depend on the branch current through branch or voltage difference between any two terminals, okay, inside the circuit. So dependent sources can be categorized in 4 parts based on the voltage and current dependency. So they can be current controlled current source or current dependent current source. They can be current dependent voltage source, or they can be voltage dependent voltage source and voltage dependent current source. Okay, so they are generally called as a current controlled current source, CCCS, current controlled voltage source, CCVS, voltage controlled voltage source, VCVS, and voltage controlled current source. Okay, so sources in which the voltage is completely independent of current or current is completely independent of the voltage, these are termed as independent sources. And some sources, special kind of sources for which either the source voltage or current depends upon a current or voltage elsewhere in the circuit, such sources are referred to as a dependent sources. So independent sources, example of independent source you can see here, a DC voltage source is there, a AC voltage source is there. So in DC voltage source, you can see that the voltage value throughout the time is constant, Vs. So it is not depending on any other parameter, and it is generally represented, the symbol of the independent source is generally represented by circular sign. Okay, so it is generally represented with a circle. So inside the circle, if we represent plus minus, if we write plus minus, it will be considered as a DC source. Okay, DC voltage source. Whereas inside the circle, if we make a symbol of sinusoidal wave shape, so that is considered as a AC voltage source. Okay, and AC voltage source, you already know that it is a sinusoidal waveform. So the waveform will look like a sine wave. Okay, and the time period of it will be 2 pi, and frequency can be calculated as you know that the omega is 2 pi f. So frequency can be calculated as omega upon 2 pi. Okay, or time period can be calculated as 2 pi upon omega, because we know that the relationship between frequency and time period is reciprocal. So the frequency time period can be represented as 1 upon f, and that we can write 2 pi upon omega in terms of t. If the axis we have taken t, the time period will be 2 pi upon omega. Okay, if we write here in the form of angle, axis we will take in the form of angle, that is omega t. So the time period will be 2 pi. Similarly, we can consider this. We can see here a DC current source, independent DC current source, and the symbol you can see here inside a circle we will represent by an arrow. If arrow is upward, it means it can be able to provide current in the upward direction. If the arrow direction is downward, it can be able to provide current in the downward direction. So the current flow direction is shown here, and inside the circle you have to represent based on the current source value and direction. Okay, direction must be there in current source. Similarly, in voltage source, whether it is means DC voltage source, the direction must be there, the plus minus direction must be there. If it is plus above, minus below, so it can able to provide current in the upward motion. If in place of plus there is minus, and in place of minus there is plus, so it can able to provide current in the downward motion. Now we can see about the dependent sources. Based on the 4 possibilities of dependent sources, we can see that current controlled current source, voltage controlled current source, voltage controlled voltage source, current controlled voltage source. Okay, so they can be categorized in 4 parts, and the symbolic representation of all dependent sources are given here in figure A to D. Okay, you can see that dependent sources are generally represented by diamond shaped symbols, where you can see that for current sources, it will be represented inside the diamond shape, it will be represented by arrow direction. Whereas for voltage sources, it will be represented by plus minus sign. If it is AC value, so it will be represented by sinusoidal wave shape. Okay. So you can see that in figure A, the value is KIX. Value is KIX. KIX means by observing the symbol of this source, dependent source, you can see that it is a current source. Okay. So by observing the symbol, it is a current source, and the value, by observing the value of its current source, you can see that it is depending on the Ix value. Ix means the current through any branch, where Ix is denoted, this dependent source is depending on that particular current. Okay, so it means it is a current source, but it is also depending on a current value of any branch. Okay, so it means it can be considered as a current dependent current source or current controlled current source. So first part is current controlled current source. Similarly, in figure B, you can see that by observing the symbol, we can see that it is a current source, whereas it is depending on the value Vx. Vx means inside the circuit, it is depending on the voltage across any two terminal mentioned in the circuit. Okay, so it is depending on voltage, but it is a current source. So that's why it is considered as a voltage controlled current source. Okay, so figure B is voltage controlled current source. Similarly, in figure C, by observing the symbol, we can see that the plus minus sign is given, means it is a voltage source and it is depending on the voltage Vx, okay, in the circuit. So it means it is a voltage dependent voltage source, or in other words, we can say that it is a voltage controlled voltage source. Okay, voltage controlled voltage source. In the last one, by observing the symbol, it is a voltage source, whereas it is depending on the value of the current through any branch, that is Ix. So that's why it is current controlled voltage source. Clear? Is it clear to all of you?
Yes, sir.
Yeah.
Yes, sir.
I think you got about the difference between independent and dependent sources. Independent sources depend on any other circuit parameters. Circuit parameters means we have only two options, either current or voltage. Okay, they are called as a circuit parameters. So if the sources, given sources, are not depending on any other parameters, they are called as a independent sources. Okay, sources can be voltage or current, you already know. But dependent sources means they will depend on the circuit parameters, means they will depend on the current through any branch or voltage across any two terminals in the circuit. Okay.
Sir, is there any example which can explain this?
Yeah, I will explain with example also. Okay, we will solve some numerical problems. While solving the circuit, we will solve some problems based on dependent sources also. Okay, don't worry. So like in the circuit, you can see that in this circuit, the source in the above circuit is a current control voltage source. So you can see that this 5 volt, it is dependent source or independent source.
Depend.
This 5 volt is dependent source or independent source?
Independent.
Independent source, because its value is fixed and it is not depending on any other circuit parameters, right? Okay, so V is just symbol of voltage. Okay, it is not related with any circuit parameter. Okay, you can see here, but you can see if we observe the shape of this diamond shape of this source, and with the polarity, we can see that it is a voltage source and the value is 10I. The value is 10I, and I, we can see in the circuit, I is given here, means the current through element C, right? The current through element C is I, and this source is depending on that current. So that's why it is considered as dependent source. Okay, so it is current controlled voltage source, right? Current controlled voltage source. If we vary the value of current I, the voltage will be, the overall voltage value will be varied. Okay. Okay. Another thing, if we talk about independent sources, so independent voltage and current sources can also be considered in two types, ideal and practical sources. Ideal sources will have some internal resistance inside. Okay. The practical sources will have some internal resistance inside. Okay. So in ideal, first we will see the ideal voltage source. This is the symbol of ideal voltage source, where you can see that the voltage value is V, current flowing through this source is I, and internal resistance, that is Rs, is equal to 0. It means in ideal voltage sources, there is zero internal resistance. So in ideal voltage sources, there is zero internal resistance. And if we talk about, if we consider the VI graph, so you can see that the voltage will maintain constant throughout the load variation. Okay. If current will be varied, there should not be any variation in the voltage. Means the terminal voltage of any voltage source, ideal voltage source, must be constant. Okay. Must be maintained constant, irrespective of the current delivered to the network. Okay. Means throughout the current variation, you can see that the voltage value is fixed. So voltage is not varying. So this is ideal voltage source, whereas in practical voltage sources, the internal resistance that is connected with the series, in series with the voltage source, it has some finite internal resistance, and due to that finite internal resistance, when current increases, the voltage, output voltage, terminal output voltage varies. So it means there is a voltage dip in the output voltage of the voltage source in practical sources. Means based on the loading, means when current value increases, the terminal output voltage will reduce. Okay. So this is the practical voltage source, the equivalent circuit of practical voltage source and the VI characteristic. Okay. Similarly, means you have to remember in this that the internal resistance of voltage source is connected in series with the source, and ideally the internal resistance value is 0, whereas in practical case there will be some finite resistance, and due to that resistance, when current increases, the overall terminal output voltage will decrease with the current. Okay. So there will be voltage dip when current increases. In case of current sources, they are also in two types, ideal and practical current sources. So in ideal current sources, you can see that the current source, in current sources, internal resistance is connected directly across the current source value. Okay, so here the source resistance is infinite for ideal current sources. Why they are infinite? Can anyone tell? Why in ideal current sources, in equivalent circuit of ideal current source, why source resistance must be infinite?
So that the current can flow 100%.
So that the current in the output can be delivered maximum. Okay. Means there should not be any current drop in this resistance. Okay. So if there is current sharing, you can see here after this branch, after passing this terminal, there are two possibilities to current flow. Okay, there are two branches, so current will divide. So when current is 0 in this branch, then only the maximum current can be given to the load or the output terminal. Okay, so that's why when the infinite value of current, infinite value of resistance, source resistance will be there in current source, then only maximum current can be delivered to the output. Okay, means in this ideal current source, you can see I output is equal to I. Exactly, it will be the value, it will be same of I value. Okay, means when voltage varies, based on the voltage variation, there should not be any change in current. Okay, current value. Whereas in practical cases, there is some internal resistance of the current source, but this resistance value must be very high. Okay, ideally it should be infinite, but practically that RS value must be very high, so that very little current can be bypassed through this source resistance. Okay, and the maximum value of current can be driven to the load. So as you can see, when the V out increases, the current, we can see the current dip is there, means I output decreases when the V output increases. Okay, when V output increases, current in this RS will increase. When current in RS will increase, I output will decrease, because I is equal to I output plus current through RS. Okay, based on the increment of V out, the current through RS will increase, and when current through RS will increase, I output will decrease. Okay, so you can see in the VI graph, the clear difference is there. When V output increases in practical cases, practical current source, current value will decrease slightly. Okay, but in practical cases, the internal resistance of current source must be very high. Okay, and in voltage source, you can see that the internal resistance of voltage source is connected in series with the voltage source. That's why to prevent the voltage drop across this internal resistance, this value must be very low. Okay, so internal resistance of practical value of internal resistance of voltage source must be very low, whereas the value of internal resistance in practical current source must be very high. And the reason I told you just now. Okay, the rest thing I will cover in the next class, and till that I will share these contents to you, okay, in Google Classroom. If you have not yet joined, if anyone have not yet joined to Google Classroom, you can join. Okay, so that you can get the contents. Okay.
Excuse me, sir.
Yeah.
Sir, can you scroll up to page 5 in this PDF? The previous one.
Previous one. In this.
Sir, above it.
Above. Okay.
Yes, sir. So slightly below. Sir, I have a doubt in these diamond-shaped symbols. Sir,
Yeah.
why are the letters K, G, and R used?
These are constant values. Okay, these are constant values. They are not variable.
Okay, sir. And sir,
Only variable is Ix and Vx. You can see
okay.
here in dependent voltage source here, 10 is the any constant value. It can be K, G, anything. Okay.
Okay, sir.
Okay, fine. Then you can join your next class. Okay.
Recording stopped.